let's take a look at another example. On average, there are about 25 imperfections in 100 meters of optical cable. What's the probability that there are no imperfections in 1 meter of optical cable? Okay, so we know our rate, lambda. On average, we see 25 defects per 100 meters of cable. That is 25 imperfections in 100 meters of cable. Okay? And we want to know what's the probability that, let's say, random variable x takes on the value of 0 imperfections in 1 meter of cable. That is, x is going to be the number of defects, imperfections, in 1 meter of cable. Okay? We want to know what's the probability that x equals 0. Probability that there are no imperfections in 1 meter. Okay? Well, this is 25 defects per 100 meters. We could rewrite that as 0.025 defects, imperfections, in 1 meter. Okay? Actually, that is 0.25. 2 zeros over, 0.25 defects in 1 meter. Okay, so we have a rate of occurrence per meter. We've got a random variable that's measured in that same interval, meters. And so we can find this pretty easily. Okay, the probability that x equals 0 is the rate, 0.25 to the 0, e to the minus 0.25 divided by 0 factorial. Okay, if we work that out, pretty straightforward. That's 0.7788. So what's the probability that we see no defects in 1 meter of cable? 0.7788. Roughly 78% of the time, if we take a meter chunk, we'll see no defects. Okay? Now, let's say we wanted to find what the probability is that there is no more than one imperfection, one defect in 1 meter of cable. Okay? No more than one. So we've got the same random variable. We still have the same interval, 1 meter. But now we want to know what's the probability that x is no more than 1. Okay? That is the probability that x equals 0, or the probability that x equals 1. Okay? That's the probability that x is less than or equal to 1. Okay? We have this. We just calculated it, 0.7788. And now we can find this. The probability that x takes on the value 1, that is, whoops, we got a plus here, 0.25 to the 1, e to the minus 0.25 divided by 1 factorial. Okay, pretty straightforward calculation. If we add those two numbers together, we should get 0.9735. Okay, so given our original rate, on average we saw 25 defects in 100 meters of cable. What's the probability that we see 1 or fewer defects in 1 meter of cable? 0.9735. That is 97% of the time, we'll see fewer than one defect in any one randomly chosen meter of cable.